In the midst of a search for a carbon-free form, all the preconceived systems are to be re-evaluated. Our concern today is the one regarding transport. As we progress to new understandings of architecture and the static connotation of the train stops is to be replaced with their redefinitions in regards to resources, movements in space, time schedules, and density correlations. Station is no more stationary. It is dynamic, adaptable, and unrepeatable in its shape and function, for it is in constant evolution and form-finding. The spatial behaviors of the inhabitants draw multiple possibilities, and these are all taken in by the architecture. The structural support of the polychronic involves cylindrical extensions, loaded with energy, thus providing non-stop fluxes of the needed products in different shapes and scales, given the spatial necessities, which by themselves rely on the individual's movements. The secondary structural order carries directly the weight of the walkable surfaces, and it is a more flexible type, since it is meant to change their positions and create specific environments for the superior layers. The last order participates in the absorption of carbon dioxide by carrying water inside. These tubes will be covered by a PEI polymer that absorbs these molecules in the air within a low range of ambient temperatures. When these rise, the carbon dioxide is released to the water flow to the membrane, to the filter tanks, provided with Escherichia coli and Pseudomonas, which process the solution into hydrogen for the train's fuel. Elevated from the floor and layered on top of the flexible support, the membranes create different atmospheres by adapting to the lower framework, but also inherently with their play of translucency and opaqueness, as well as the temperature's fluctuation. The primary structure is braced with tensils and pulleys, while the secondary one involves elastic stripes. It is the merging of all those systems working simultaneously what allows to achieve a more complex and richer spatiality, where the architecture is able to respond and adapt to its real situation. Lastly, while playing with the existing plane surfaces, topographies are projected with piezoelectrics attached to them. These are embedded onto the surfaces and accumulate heat with pressure. Within the mere act of depressing the horizontal skin of the building, energy is produced in order to push the whole system into activation and create suitable atmospheres both in a tangible and sensible way. This whole sensible system is served by different technical locations within the lower section of the topographies. The automatic servers are also linked to the main tube structure in order to distribute supplies along the station. A number of possibilities of these spatial behaviors is set to provide a living organism that moves and shapes itself into desired and necessary forms based on the activities. Their weight equals energy, and this one is then used to secure the force of the system through the electrical capacity of the topographies. After all, resources, temperature, and humidity should be used as spaces by themselves, spaces that harvest energy due to the densities and movements. Overcoming carbon form not only needs to change the way we build and live, but also our approach to aesthetic architecture conceived to last unalterable in a future that it is not.